So, a very good evening to all, and welcome to the class. In this class, we are going to solve the questions related to the hydrocarbon. So, in previous classes, in the Saturday Sunday classes, we already covered questions on GOC part, right? So, this is also quite related to the GOC hydrocarbon. So in this, we are going to solve some numerical related to hydrocarbon as well as some one or two questions from GOC as well, because these are interconnected part. So this is going to be a very interesting class for all of you. I hope all of you join the session, right? Chalo. So let's start with the problem solving. Yeah, the first question is among the given option, which of the following molecule or ion act as a Lewis acid, right? So in this they are asking among the given option, which of the following molecule ion act as a Lewis acid? So we have H2O, we have a BF3, we have a OH negative, and we have NH3. So I hope all of you know that, right? This is a very simple question. So we know that is what is the Lewis acid basically. So Lewis acids are those which having the deficiency of electrons, right? So those having the deficiency of electrons are known as Lewis acid. Similarly, Lewis bases, what is Lewis bases beta? Lewis bases having the lone pair of electron. So they're having a tendency to donate this lone pair of electron. So they are known as Lewis base, right? So we have a two things, Lewis acid, deficiency of electron, Lewis base having electron to donate. So in this, they are asking which of the following is a Lewis acid. So we all know H2O is a H2 having the lone pair, right? In H2O, the oxygen having the lone pair of electron. So they behave as a Lewis base. In BF3, we have a 3BF, right? And they have only six bonds. So their octet is incomplete, right? They having only six electrons. So they behave as a Lewis acid because they have a deficiency of electron. So they behave as a Lewis acid, right? Similarly, OH negative means they having extra electrons. NH3 again, they're having one lone pair. So they all behave as Lewis base. So only correct option is BF3 beta, right? Only correct option is BF3, where all act as a Lewis base. Only BF3 act as a Lewis acid. So this is a very simple question. I hope सबको समझ आया होगा ये, है ना? चलो. Now move to the next question. That is the decreasing order of boiling point of the following alkane, right? So you have to arrange them in the order of their decreasing boiling point of alkane. So this is again a very simple question from the hydrocarbon, and these questions come in NEET 2022 paper, right? So this is a very interesting question. So let's see how will you find the order for the boiling point, right? So on which factor this boiling point depend? Can anyone tell me, right? Can anyone tell me on which factor the boiling point of alkanes depend? Basically, the boiling point of alkanes depend upon first, that is the molecular masses, number of carbon content. As the number of carbon content increase, definitely boiling point also increases. Second thing, that is a branching. As the branching increase, boiling point decrease. So the first factor is that is the number of carbon atom. Number of carbon atom. नंबर ऑफ कार्बन एटम. तो ये पहला चीज है जिस पे डिपेंड करता है हमारा क्या बॉइलिंग पॉइंट. सेकंड जिस पे बॉइलिंग पॉइंट डिपेंड करता है इज दैट इज आफ्टर नंबर ऑफ कार्बन एटम वी हैव टू नो द सेकंड थिंग दैट इज द branching, right? That is branching. So as the branching increase, branching as branching increase, ठीक है. So as the branching increase, what happened? As the branching increase, that is boiling point decrease. Boiling point decrease. So these two factors on which the basically the boiling points of alkane depends, right? That is the number of carbon atom and the branching. So as the branching increase, boiling point decrease. So बस ये दो factors लगा के यहाँ पे देखो सबसे ज्यादा किसका होना चाहिए? सो वी हैव अ हेप्टेन, वी हैव अ ब्यूटेन, we have a 2-methyl butane, 2-methyl propane, and we have a hexane here. So obviously, if we talk about the number of carbon atom, right? If we're talking about the number of carbon atom in heptane, the carbon there is a 7 carbon atom, right? So definitely heptane having the maximum boiling point. So the heptane having the first one, right? So A having the maximum. So out of three option in which A have a maximum, three option. So just neglect option C, because in this C having the maximum, which is not the correct one, because A having the maximum number of carbon now, that's why heptane having the maximum boiling point. The first thing is clear. Now, after we have butane and then we have hexane, right? So again, in hexane we have a 6 carbon atom. So definitely after heptane we have a hexane. Then A के बाद क्या आना है? E, right? So this A and E is absolutely true. Now, move to the next, that is butane, and we have a 2-methyl butane and 2-methyl propane. So, we have a butane and 2-methyl butane. So, out of these, which one of the following having the highest boiling point, right? So, let me consider draw the structure of right butane. So, structure of butane is nothing but CH3, that is CH2, CH2, and this is CH3. So this is the structure of butane. Now we also have a structure 2-methyl butane, that is CH3, that is C, that is CH3, again CH, CH2, and again this is we have CH3. So this is butane and this is 2-methyl butane, right? This is butane and 2-methyl butane we have. Clear? So this is butane and 2-methyl butane. So obviously in this the number of carbon is more now, because here we have only 4 carbon. So the molecular masses of 4 carbon only, but here we have a 5 carbon. So the molecular masses of 5 carbon is definitely greater than this 4 carbon. So then comes 2-methyl butane. It means C. After C, we have a 2-methyl propane and we have a butane. So 2-methyl propane, in this case, the branching increases, right? In this case, the branching increases. This is the structure, because here also we have a 4 carbon. Here also we have a 4 carbon in butane and in 2-methyl propane. In all these cases, we have a 4 carbon atom. So obviously, as the branching increases, if the same number of carbon atoms are there, and if the branching increase, then boiling point start decreasing. It means out of 2-methyl propane and butane, obviously butane having the higher boiling point. So then comes B and then comes D. So option A is absolutely correct. ठीक है, तो आई गेस सबको समझ आ गया होगा ऑप्शन ए कैसे करेक्ट हुआ। क्या क्या देखना है? एक तो कार्बन एटम को देखना है, दैट इज नंबर ऑफ कार्बन एटम। सेकेंडली क्या देखना है? ब्रांचिंग, कि एज द ब्रांचिंग इंक्रीज होगा बॉइलिंग पॉइंट डिक्रीज होने लग जाएगा। तो सबसे पहले तो नंबर ऑफ कार्बन एटम देखो। सो वी हैव अ 7 carbon in case of heptane, obviously much more. Then we have a 6 carbon in case of hexane, and after this heptane and hexane, ठीक है। अब हेप्टेन और हेक्सेन के बाद क्या बचा? तो ब्यूटेन एंड 2-methyl butane. So obviously in 2-methyl butane we have a 5 carbon, in butane we have only 4 carbon. So इस तरीके से हम लोगों ने पूरे ऑर्डर को अरेंज किया है। क्लियर है ये सब? चलो next, the incorrect method, right? In this, they are asking the incorrect method for the synthesis of alkene. So they are asking for the synthesis of alkene, which of the following is the incorrect method, right? So the first one is alkene का synthesis करने के लिए, that is treating vicinal dihalide with zinc metal. So this is absolutely true, beta, because we all know what is vicinal dihalide. Can anyone tell me? What do you mean by the term vicinal dihalide? Anyone wants to add anything to this? Vicinal dihalide. Chalo, let me explain this to you. Right. So vicinal dihalide means beta we have a halogen group on the adjacent carbon atom, right? For example, we have a CH2Br, again we have a CH2Br, right? And when this is treated with the zinc, when this treated with the zinc, so when the CH2Br is treated with zinc, then what you'll get? You'll get a CH2 double bond CH2, that is alkene. Alkene. So we get alkene. So by this method we can prepare alkene. So this is not the incorrect method, right? This is the correct method. Again, treating of alkyne with the Na in liquid ammonia. So we all know this. Whenever we treat alkyne In the liquid ammonia we get the trans alkene, right? So this thing we also know कि whenever we treat alkyne in a liquid ammonia, right? Liquid ammonia, sodium and liquid ammonia, we get a trans alkene, right? This is C double bond C, and here we have R, here we have R dash, here we have H, here we have H. So in this also you'll get the alkene. So this is also correct. Next, heating alkyl halide with alcoholic KOH. So this is a very simple beta elimination reaction. That whenever you treat CH3, CH2, Cl with alcoholic KOH, you'll get ethene. CH2 double bond CH2. So in all this method, you'll getting alkene. So obviously option D is going to be correct, right? Because only option D is left. Let me explain this also. Treating alkyl halide in aqueous KOH. Because when you treat CH3, CH2, Cl in KOH, right? Which KOH? Aqueous. Then what you'll get, beta? KCl is removed. You'll get a CH3, CH2, and OH. So alcohol will be formed. Alcohol will be formed. So this is not the correct way, right? So which option is correct? Because in this they are asking the incorrect method. So the incorrect method for the synthesis of alkene is nothing but the treating alkyl halide in aqueous KOH solution. I hope this is clear to everyone. Clear है सबको क्या? जल्दी बता दो एक बार फटाफट. Because when you treat vicinal dihalide with the zinc metal, you get alkene. When you treat alkyne in sodium with liquid ammonia, you'll get trans alkene. When you treat alkyl halide with the alcoholic KOH, then also you'll get the alkene. So only correct option is that is the treating alkyl halide in a aqueous KOH. So this is the correct way, correct option for this question. Right. I hope सबको समझ आ गया होगा यहाँ तक. हम्म. चलो. Move to the next question, बेटा. Yeah. Yes, sir. Ashika. Good, beta. Chalo. Move to the next question. Yeah, this is very interesting question, beta. And this question, I guess, this question was came in NEET 2021 paper, right? So this is a previous year question, right? All these questions are the PYQ of JEE and NEET, right? Now, the question asks the correct structure of 2,6-dimethyl deck 4-ene is. So we have this structure. We have a four option for this. So the correct structure for this, can anyone tell me the correct structure of 2,6-dimethyl 4-decene, right? So we have a three option, right? A, B, C. uh, I didn't show you fourth option. So out of these three only, one is the correct one, right? Out of A, B, and C. So can anyone tell me which one is going to be the correct option? Hmm? Which one? Fatafat. You have to draw the structure of the 2,6-dimethyl deck 4-ene. So let me no number the hydrocarbon, right? So first of all, you select the longest chain, right? Whenever you have to name the compound, you have to select the longest chain. After the selection of longest chain, numbering should be done by using a proper rule, right? So we have a deck 4-ene. Deck means 10 carbon, right? Deck means 10 carbon. And 4 we have ene, right? So from where we'll start our numbering. For example, if we start numbering from here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we number select the longest chain as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 4 we have ene, right? So 4 we have ene. So we have a 10 carbon atom deck, and 4 we have ene. So 4 we have ene. No functional group is present. Fine. So let's look for the substitute. So we have a 2 and 6, right? 2 comma 6 dimethyl. So we have a 2 comma 6 dimethyl, 2 comma 6 dimethyl, and this is deck 4-ene. So I hope everyone सबको समझ आ गया होगा कि ऑप्शन ए इज द करेक्ट, राइट? ओनली ऑप्शन ए इज द करेक्ट. So the correct structure for 2,6-dimethyl deck 4-ene, nothing but option A, because this is a very simple just UPSC naming, right? क्लियर है सबको? क्या एक बार कंफर्म करो. सबको समझ आ गया? हम्म, राइट। सो ये है करेक्ट ऑप्शन, दैट इज ऑप्शन ए। ठीक है, चलो। Now, this is also going to be a very, very, very interesting question. That is, as alkene on ozone give methanol, not methanol, beta. This is methanol. So, methanol as one of the product, its structure is. So, what is the basis of ozone lysis? We all know this. In ozone lysis, basically what happening. For example, if the ozone lysis of this alkene will takes place, then what happening, what is the basic criteria behind ozone lysis? Always एक ही रूल फॉलो करना है बेटा। ये देखो डबल बॉन्ड दिख रहा है, यहां से इसको ब्रेक करो, ट्राई टू ब्रेक देम, और एक ओ इसको दो, गिव वन ओ टू दिस साइड, गिव वन ओ टू दिस साइड, काम खत्म। और एक ओ जेड एन के साथ निकल जाता है, जेड एन ओ वन के, तो उसको भूल जाओ। ठीक है, सो एक ओ इसको दिया तो क्या बना, सी एच थ्री सी एच ओ, एंड अगेन क्या बना, सी एच थ्री सी एच ओ। सो हमें क्या मिला, 2 मोल ऑफ इथेनॉल। सो वी गॉट द 2 मोल ऑफ इथेनॉल। सो ये क्राइटेरिया आपको फॉलो करना होता है। सेम वी हैव अ डबल बॉन्ड हियर। सो इफ यू ब्रेक लाइक दिस, then you'll get this thing and this thing. So definitely you can't get methanol out of this, because we get the ring-like formation, right? So you can't get the methanol in this product. Now, if you break this, then you'll get methanol. Yes, obviously you'll get. How? देखो यहाँ से ब्रेक करो, सो एक दो, तो ये क्या बना, एक पार्ट बना हमारा, दैट इज CH2। अगेन गिव वन O टू दिस साइड एंड वन O टू दिस साइड। सो क्या बना, CH2 CHO, right? CH2 CHO, right? And इधर क्या बना, we have HCHO, that is called methanol, right? This is called methanol. This is called methanol, right? Also known as formaldehyde. So this is the correct option, beta. That is, and as alkene on ozone lysis give methanol as one of the products. So structure is this. So this structure give methanol as one of the product. Chalo. The next question is the most suitable reagent for the following conversion. So अभी अभी पढ़ा था, if you want trans-alkene, then you use this sodium and liquid ammonia. But here you want a cis-but-2-ene, right? Here you want a cis-but-2-ene. So obviously this option is not there, right? This option is eliminated, right? So which option is correct? So always remember, beta, whenever you want, whenever you want trans-alkene, you can use sodium and liquid ammonia. And whenever you want to prepare cis-butene from the alkyne, you have to use an reagent called H2PDC, right? And this is known as a syn addition. So this is an example of syn addition which takes place in the presence of H2PD, right? PDC, right? And this is known as syn addition. Syn addition. Okay, so this is known as syn addition. So most suitable region for the following conversion is this H2PTC in presence of this is also known as a syn addition, right? So option D is correct. So which option is correct, beta? Option D. Now move to the next question, that is a hydrocarbon. This is a very, 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 very good question. That is a hydrocarbon A react with bromine by the substitution to form an alkyl bromide, which by Wurtz reaction is converted to gaseous hydrocarbon containing less than 4 carbon atom. Containing less than 4 carbon atom. So you have to identify this hydrocarbon. ठीक है, so एक hydrocarbon A react with a bromine by the substitution to form alkyl bromide, then they will undergo Wurtz reaction and is converted to a gaseous hydrocarbon containing less than 4 carbon atom. So A is. So let me explain this. This is alkyne, so this is not react. This will also not react. So we have left with only two options. That is either this alkane or this alkane, right? Because we know with the substitution reaction will takes place only with the alkane only, right? So only these two options will come into the picture, that is either C or D is the correct answer. या तो C होगा या D होगा. Now out of C and D which one is correct? देखो, So hydrocarbon A react with the bromine. So let me tell you one thing, because in they are clearly mentioning कि they are converted into a gaseous hydrocarbon containing less than 4 carbon, right? So 4 carbon से कम होना चाहिए. That's why I'm not taking this CH3 CH3, right? Why? अगर मैंने CH3 CH3 को लिया, then what happened? Then ये more than 4 carbon बनाएगा. अभी explain करता हूँ. For example, we took CH4. This CH4 react with bromine, that is Br2, in presence of sunlight to form CH3Br. क्या बनाएगा? CH3Br. So this CH4 react with Br2 in presence of sunlight to form CH3Br. Now, this CH3Br undergo Wurtz reaction. So we know in what happened in the Wurtz reaction. CH3Br, 1 mole of the alkyl halide react with the 2 mole of sodium. So again, we have to take one more molecule of this alkyl halide, right? So this 2 NaBr is as a byproduct, 2 NaBr. So we left with the CH3 and CH3, that is ethane. Right, so you'll get ethane, ethane. So this is the correct one, right? If you'll take instead of CH4, if you will take this CH3 and CH3, when you react with the Br2, तुम्हें क्या मिला होता? CH3, CH2 and Br. Now when they undergo Wurtz reaction, तो क्या मिल जाता बेटा? देखो, CH3 CH2 Br. So 2 NaBr तो निकल जाता है the byproduct. So you'll get butane. That is CH3, CH2, CH2 and CH3. But in this question ये clearly mentioned था कि you have to convert to the gaseous hydrocarbon containing less than 4 carbon. So ये तो 4 carbon हो गया, इसीलिए हमने ये नहीं लिया. So which option is correct? D. तो ऑप्शन डी इज एब्सोल्युटली करेक्ट फॉर दिस. ठीक है, एक हाइड्रोकार्बन ए रिएक्ट कर रहा है ब्रोमीन के साथ, सब्स्टिट्यूशन रिएक्शन विद टू फॉर्म अल्काइल ब्रोमाइड, और फिर वो अल्काइल ब्रोमाइड जो है वो वुड्स रिएक्शन शो कर रहा है. ठीक है, एंड उसके बाद वो हाइड्रोकार्बन बना रहा है कंटेनिंग लेस देन 4 कार्बन एटम. तो ए क्या होगा? तो ये क्या होगा? मीथेन होगा ये. ठीक है, चलो, वेरी गुड. Now move to the next question. This is a D 2017 question, right? So what they are asking basically, which one of the correct order of acidity? So they are asking the correct order of the acidity. Which one of the correct order of the acidity, right? So for the acidity, we all know that greater the character of carbon atom in the hydrocarbon, greater the electronegation of the carbon, and thus greater is the acidic nature of the hydrogen atom, right? So greater the character of carbon atom. Always remember carbon atom. So greater the character of carbon atom. कार्बन एटम का कैरेक्टर जितना ज्यादा होगा, ऑब्वियसली इलेक्ट्रोनेगेटिविटी उतनी ज्यादा होगी. इलेक्ट्रोनेगेटिविटी इज मच मोर, एंड एज मोर द इलेक्ट्रोनेगेटिविटी, मोर एसिडिक नेचर विल बी. ठीक है, और इसी से एसिडिक नेचर भी डिफाइन होगा. ठीक है, यानी ग्रेटर द कैरेक्टर ऑफ कार्बन एटम, मोर इलेक्ट्रोनेगेटिविटी, एंड ड्यू टू दिस मोर इलेक्ट्रोनेगेटिविटी, acidic character increase, right? So out of these, we have in this we have ethyne, right? So we can say that, right? So here we have this ethyne. Let me draw the structure of this ethyne. We have CH triple bond CH. Again, in this we have CH3, and this is C triple bond CH. And in this we have CH2 double bond CH2, and then we have CH3 and CH3. So this is alkyne, terminal alkyne, right? So you all know that terminal alkyne are very acidic in nature. यहाँ पे बहुत ज्यादा acidic होगा due to this triple bond. ये H plus का निकलना easy होगा. ठीक है, ये H plus आसानी से निकल जाएगा. ठीक है, यहाँ पे H plus का निकलना बहुत easy है. Then comes this alkyne, then comes alkene, then comes alkene, right? Also remember one thing, sp hybridization, sp2 hybridization, and sp3 hybridization. So sp hybridization having the maximum acidic character, right? sp having the maximum acidic character, then come sp2 and then sp3. So obviously alkene. So most acidic is alkyne, then comes alkene, then comes alkane. So out of alkene and alkyne, we all know that alkyne having the sp hybridization, alkene having sp2 hybridization, and alkane having the sp3 hybridization. So this is the order. Now these two, अगर इसमें डाउट हो किसी को कि तो दोनों एल्काइन है, फिर इन दोनों एल्काइन में हमें कैसे पता लगा कि ये वाला ज्यादा एसिडिक है? बिकॉज ये टर्मिनल एल्काइन है बेटा। सो टर्मिनल एल्काइन में दोनों बगल देख रहे हो, यहाँ पे बहुत ट्रिपल बॉन्ड है, तो यहाँ से एच का निकलना थोड़ा सा आसान होगा एज कम्पेयर टू दिस। ठीक है, यहाँ पे एक डोनर ग्रुप की तरह ये CH3 काम कर रहा है, इसीलिए यहाँ पे निकलना थोड़ा सा मुश्किल होगा, बट यहाँ पे एच का निकलना बहुत इजी होगा प्रोटोनेशन। दैट्स व्हाई दे आर मच मोर एसिडिक। सो विच ऑप्शन इज करेक्ट बेटा? ऑप्शन नंबर ए। सो ऑप्शन ए इज एब्सोल्युटली करेक्ट फॉर दिस। ठीक है, आई गेस सबको समझ आया। चलो, सो दिस इज अगेन अ वेरी वेरी इंटरेस्टिंग क्वेश्चन, that is, predict the correct intermediate and product in the following reaction. So we have CH3CCH, that is alkyne we have, and when you treat this alkyne with H2H2SO4 in the presence of mercury sulfate, you will get intermediate A, then they convert it into B. So this is a very very simple method, right? And this method will use for the preparation of aldehyde and ketone from the alkyne, right? So this is going to be very very interesting. So here we have first step we have H3C C, and here we have a triple bond CH and H2। तो H2 का एडिशन कैसे हो रहा है यहाँ पे देखो ध्यान से, मार्कोनिक एडिशन। So ये H2 ही लिखा है मैंने इस तरीके से, OH negative and H plus. So the negative part goes to the those carbon atom which contain the lesser number of carbon, right? So this thing we already know according to the Marconi's rule, that is नेगेटिव पार्ट गोज टू दोस कार्बन एटम व्हिच कंटेन द लेसर नंबर ऑफ हाइड्रोजन। सो ये OH कहाँ जाने वाला है जल्दी बताओ? तो ये OH गया यहाँ पे, और ये H कहाँ गया? यहाँ पे। सो व्हाट यू विल गेट एन इंटरमीडिएट लाइक CH3 C, we have OH, and double bond we get CH2। so this is the intermediate we got। तो ये तो मिल गया इंटरमीडिएट। कौन सा सही है भाई? CH3COH डबल बॉन्ड CH2। सो ये इंटरमीडिएट बन गया, यहाँ भी है यहाँ भी है, गुड। नाउ फिर यहाँ पे होता है टोटोमेरिज्म। क्या होता है? टोटोमेरिज्म, दैट इज टोटोमेरिज्म। So after tautomerism, it will convert it like CH3C double bond O, and this is CH3। So you'll get acetone। You'll get acetone। ठीक है, क्या मिल गया? एसीटोन मिल गया भाई हम सबको। सो कौन सा सही होने वाला है? यस, ऑब्वियसली ऑप्शन सी। सो ऑप्शन सी इज एब्सोल्युटली करेक्ट। सो you'll get intermediate like this alcoholic group, and they will convert it into ketonic group, right? So intermediate is OH and final product is ketone। So this is the correct option, option number C। सबको समझ आया क्या? एक बार कंफर्म कर दो। एवरीवन गॉट इट? चलो, now, with respect to the conformers of ethane, which of the following statement is true? Right. So, with respect to the conformance of ethane, which of the following statement is true? That is, the bond angle change, but the bond length remains same. The next is bond both bond angle and bond length change. Both bond angle and bond length remain same. Yeah, both bond angle remain same, but the bond length change. So which of the following option is correct? So beta, always remember with respect to the conformers of ethane or either ethene, both bond angle and bond length remain same, right? So that's why they are known as the conformers of ethane, right? Conformers are the isomer, right? Conformers are nothing but the isomer which are formed by rotation, which was formed by the rotation about the single bond without any cleavage of any bond. These conformants have the same bond angle between them and have same bond length while their dihedral angle changes. So always remember both bond angle and bond length remain same. Okay. So which option is true beta? That is option number C। Now, which of the following can be used as a halide component in the Friedel-Crafts reaction? ठीक है. So in case of Friedel-Crafts reaction, which of the following can use as the halide component? ठीक है. So let's discuss which of the following can be used as the halide component for the Friedel-Crafts reaction. So let's see, we have benzene, right? So we have benzene, and this will react, right? This will react with the CH3, CH, CH3, Cl in presence of anhydrous AlCl3, right? So this benzene, this react with this anhydrous Cl3 to form to form CH CH3 CH3, right? That is called cumene. This is also known as cumene. So which is used, beta? That is the isopropyl chloride, right? So isopropyl chloride will we are using. So in this question, they're asking which of the following can be used as the halide component for the Friedel-Crafts reaction. So we are using this isopropyl chloride, right? So basically, why we are not using chloro, bromo, and chloroethane? Let me explain this thing. So chlorobenzene and bromobenzene and chloroethane, right? Both, all of these three are not the suitable halide component, as the lone pair of electron of halogen are delocalized with the pi bonds to attain double bond character, right? Because in chlorobenzene, bromobenzene, due to resonance, they have a strong tendency to behave as act as a CX double bond, right? So due to this, in chloroethane also we have a CH3, CH2, and Cl. So in this also, due to the presence of lone pair of electron, they have a strong tendency to no delocalize the pi bonds and attain double bond character. That's why we are using isopropyl chloride. So this isopropyl chloride are the better, or we can say that they are used as a halide component for the Friedel-Crafts reaction. ठीक है, everyone. Now, this is again going to be a very, 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 very interesting question. So all of you need to calculate in pyrone the electron density is maximum as. So at which point the electron density is maximum, right? So you have to calculate at which point electron density is maximum. So remember beta, at point 2 and at point B, because we have a lone pair of electron in nitrogen. So due to this only, at point 2 and point 5, they show the maximum electron density. So in pyrrole, the electron density is maximum at 2 and 5. Why? Because at 2 and 5, we have a lone pair of electron, right? So when the attack at point 2 and 5 will take place, the electron density is maximum. Therefore, the maximum electrophile attack on position 2 and 5 only. Okay? Now, consider the nitration of benzene using a mixture of concentrated H2SO4 and HNO3. Right? Consider the mixture of H2SO4 and HNO3. If a large amount of KHSO4 is added to the mixture, the rate of hydration. Okay, you have to explain what happened to the rate of hydration, whether the rate of hydration will be changed or not. Right? So they are asking nitration of benzene using a concentrated H2SO4 and HNO3 we are using. Now instead, if the large amount of KHSO4 is added to the mixture, the rate of nitration will be. So what is the role of this KHSO4 here? ठीक है, यही क्वेश्चन है कि यहाँ पे रोल क्या है KHSO4 का. How they you know impact on the rate of reaction, whether the rate of reaction will become slow, become faster, become double, or we say it remains unchanged. तो ये देखना है आप लोगों को, तो चलो देखते हैं. Basically, why you use H2SO4 and HNO3? Let me explain this thing first, then we will come to the KHSO4. So basically, H2SO4 are used in nitration because they are used to generate an electrophile, right? So they are able to generate an electrophile, that is NO2 plus. Now they react with the HSO4 negative plus hydronium ion, that is H3O plus. ठीक है? So this is H2SO4 plus HNO3. They react with the NO2 plus and HSO4 negative plus H3O plus. ठीक. So यहाँ पे हमें क्या मिला है? NO2, which is act as a electrophile. Now, this KHSO4 will produce K plus and HSO4 negative. Remember this thing beta. So due to the common ion effect, देख रहे हो यहाँ भी एक आयन है, यही आयन यहाँ भी है, तो ये कॉमन आयन इफेक्ट हो गया. तो ड्यू टू द कॉमन आयन इफेक्ट backward reaction will takes place, so the formation of NO2 plus. So the formation of NO2 plus decrease. So nitration process will become slower. So this is very interesting question. बहुत अच्छा क्वेश्चन था ये. हुआ क्या, ध्यान से सुनो. हमें पता है हम H2SO4 HNO3 को जब मिक्स करते हैं तो हमें NO2 मिलता है which act as a electrophile. NO2 क्यों मिलता है? क्योंकि HSO4 का फॉर्मेशन होता है. HSO4 का अगर फॉर्मेशन ना हो तो हमें NO2 प्लस भी ना मिले. अब हुआ क्या, जैसे इस मिक्सचर में यू पुट KHSO4, so KHSO4 decompose to give K plus and HSO4 negative. So we have a 2 HSO4, this is called common ion effect. ये एक ही सॉल्यूशन में जब दो आयन आ जाते हैं सेम, तो उसको बोलते हैं कॉमन आयन इफेक्ट. एंड ड्यू टू दिस कॉमन आयन इफेक्ट a backward reaction will be takes place, so the formation of NO2 plus decrease, so we can say that nitration process become slower. So this is the effect of adding large amount of KHSO4 to the mixture, the rate of nitration become slower. Everyone, सबको समझ आया? Everyone got this question? सबको समझ आ गया? चलो. Now the next question is, that is the correct statement regarding the comparison of staggered and eclipse conformation of ethane, right? So let me here draw the conformation of the ethane, that is both the staggered and eclipse form. Okay, so let me draw here, right? So we have a 3H. So यहाँ पे 3H बना लो, एक H ये रहा, एक H ये रहा, एक H ये रहा, 3H हो गए. ये देखो, एक H यहाँ पे है, एक H यहाँ पे है, और आपका एक H ये रहा. ठीक है. सो दिस इज कॉल्ड द एक्लिप्स फॉर्म. इसको कौन सा फॉर्म बोलते हैं बेटा? एक्लिप्स्ड फॉर्म. दिस इज कॉल्ड एक्लिप्स्ड. ठीक है. अब होता है कि स्टैगर्ड. तो स्टैगर्ड फॉर्म कौन सा होता है उसको भी बना लेते हैं. ये देखो, यहाँ भी 3H बनाओ, एक H, दो H, 3H. अगेन वी हैव 1H हेयर, 1H हेयर, 1H here. So we can see that here the dihedral angle is more, right? So this is called angle of rotation. Angle of rotation. This is called angle of rotation, or we say dihedral angle. Dihedral angle. So this is called angle of rotation, or we say dihedral angle. Clearly, and this is known as staggered form. Staggered. So this is known as staggered form. So this is the eclipsed form. This is the staggered form. Now you carefully read the option. So the option is like the eclipse conformation, ethane is more stable. So we can't say the eclipse form is more stable because here the angle is very less, right? Here the angle is more, so the staggered form is much more stable. In option B, the staggered conformation of ethane is more stable than eclipse form because the staggered conformation has no toroidal strain. So ये बिल्कुल सही बोल रहा है because यहाँ पे एंगल ज्यादा है. तो अगर एंगल ज्यादा होगा, so due to this, no, they are having no toroidal strain. Option C state that the staggered conformation of ethane is less stable than eclipse form. No, this is not the true one. The eclipse conformation of ethane is more stable then staggered conformation, because eclipse conformation has no torsional string. So only option B is correct, beta. Rest all options are incorrect. Eclipse form is never stable as compared to staggered form, because in staggered form the dihedral angle is very much right, and more the dihedral angle, more stable and having the no torsional string, and lesser the dihedral angle, more the torsional string. ठीक है, तो इसको याद रखना है बेटा, दे आर द स्टैगर्ड फॉर्म इन विच द डाइहेड्रल एंगल इज गुड, यानी डायहेड्रल एंगल थोड़ा सा ज्यादा होता है। ठीक है, तो इसको आपको समझ के रखना है, राइट। Okay, move to the next question. That is the pair of electron in the given carbocation, that is CH3C triple bond C negative, is present in which of the following orbitals, right? So you have to calculate the pair of electrons in the given carbon ion. This is the carbon ion, carbon having the negative charge, is present in which of the orbitals. So let me explain this. So we can say that, let me calculate the hybridization. So this is CH3, C, triple bond, C, negative. So here the hybridization is like 1 and 1, 2. So that is sp. Here also 1 and 1 lone pair of electron. So they are sp, right? So thus the pair of electron is present in the sp hybridization. So it's a very simple question. So we can say that the pair of electron in the given carbon ion is present in a sp hybridization. Okay? Now, so this is again a very interesting question. They are asking, we have alkyne, and when we treat this alkyne with the NaNH2 in liquid ammonia, again in the second step CH3 CH2Br will get X. When X treated with NaNH2 liquid ammonia, CH3 CH2Br will get Y. They are asking what is X and what is Y. Okay, so let me explain this thing. So first of all, when this HC triple bond CH, and when they are treated in the presence of sodium in liquid ammonia, that is liquid ammonia, okay, and in presence of NaNH2, NaNH2, what you'll get, beta? SC triple bond C and Na, right? C and Na. Now when they treated with the CH3 CH2Br, CH3 CH2Br, NaBr तो एक निकल जाएगा एज अ बाई प्रोडक्ट, तो NaBr तो गया, क्या मिला फिर? we'll left with CH triple bond C, CH2 and CH3. So this is X. ये मिला X. That is ब्यूट वन आइन, ठीक है, या और इज वन ब्यूटाइन। सो ये मिल गया वन ब्यूटाइन। अब सिमिलरली अगर मैं इसको ट्रीट करूं अगेन विद NH2 बराबर, देन विल गेट एस, जल्दी बताओ फटाफट क्या मिलेगा। सो हम लोगों को मिल गया, हम्म, सो हम लोगों को मिल जाएगा यहाँ पे अगेन, वी गेट सी ट्रिपल बॉन्ड हियर ना, सो वी कैन राइट एज CH3 CH2 C triple bond C Na, right? C triple bond C Na, and in the last step when they are treated with the CH3 CH2Br, NaBr निकल जाएगा, and we are left with CH3 CH2 C triple bond C, CH2 and CH3. 1 2 3 4 5 6, 1 2 3 4 5 6, yeah, that is hex 1 2 3, hex 3I, right? So we'll get the product like one butane and hex 3 hexane. So this is the product you'll get as a X and Y, that is one butane and 3 hexane. Clear है सबको? कैसे मिला ये product? That is one butane and 3 hexane. Done? So this is X and Y in this given equation. Chalo. Move to the next question, that is 2,3-dimethyl 2-butene can be prepared by heating which of the following compound with a strong acid. So they are asking 2,3-dimethyl and 2-butene can be prepared by heating which of the following compound with a strong acid. So you need to prepare 2,3-dimethyl butene. So let me draw the structure of this, what you need to prepare. That you want to prepare CH3 C double bond C. Here you want CH3 CH3 and CH3. So this is you want to prepare. That is 2,3 dimethyl but2ene. Okay. And you have this all four option. So by heating which of the following compound with the strong acid, you'll get this. So let me explain this. We have CH3, 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 right? And this is CH double bond CH2, right? Now, when you heat this alkene in presence of some strong acid, what you'll get? You'll get a CH3, C, CH3, CH3, and here carbocation formation will be takes place. So it's become CH and this will become CH3. So this is known as a second degree carbocation. Now here alkyl shift will takes place. क्या हो रहा है यहाँ पे? Alkyl shift. Alkyl because tertiary alkyl बनेगा ना. So alkyl shift होगा बेटा यहाँ. Due to this alkyl shift, this will become the tertiary carbocation. How? देखो CH3, C पे पॉजिटिव चार्ज आ गया. This will become again CH3, CH, again CH3 and CH3. So this will become tertiary carbocation. हुआ क्या है? एक alkyl का shift हुआ यहाँ से यहाँ पे. ठीक है? Alkyl shift. Now this will become carbocation. अब इसको आप जैसे ही H plus के साथ heat करोगे, so you'll get this product, right? So you'll get this product like CH3C, CH3, CH3. That is 2,3 dimethyl but2ene. That is option A. So option A बिल्कुल correct है इसके लिए. ठीक है? चलो. So a single compound of the structure is optimal from the ozonolysis of the following cyclic compound. So किसका ozonolysis आप करोगे कि आपको ये प्रोडक्ट मिलेगा. ठीक है? So this product, that is the a single compound of the structure is given, is obtained from the ozonolysis of which of the following cyclic compounds. So we have option like this. Uh, Let me explain this thing. Right? So the correct answer is like if you ozonize this ring in this because option is not given. So I'll explain this question. If you ozonlysis, right? If you ozonize this, that is CH3. Here we again have a CH3. So if you ozonize this, then you will get this product, right? How? Because this is treated with O3, right? So when you treat with the O3 in first step and the second step, you are treating with the zinc and H2O. So what you'll get, beta? You'll get the product like OHC, that is CHO. Again, you will get CH2, CH, CH2, C. Here you'll get CH3, C double bond O. Here also CH, we have CH3. Right. So if you treat this alkene, then you'll get this. इसका ऑप्शन नहीं था क्वेश्चन में, इसलिए मैंने एक्सप्लेन किया. वैसे आप क्वेश्चन देखोगे तो इसमें ऑप्शन आपको मिलेगा. ठीक है? सो ऑप्शन लाइक दिस ओनली. So this is the correct one. Now, what products are formed when the following compound is treated with Br2 in presence of FeBr3? So क्या बनेगा भाई अगर आप इसको ट्रीट कर दो तो जल्दी बताओ. So what product will be formed when the following compound is treated with Br2? When following compounds are treated with Br2 in the presence of FeBr3. So we all know that the Br2 whenever they are treated with Br2, so ortho-para substituting groups are formed. So methyl group is ortho-para directing, but due to the steric hindrance effect generated by the two CH3, two bulky group. This is the two bulky group. Otherwise, CH3 group is the ortho-para directing group. But the steric hindrance produced by these two bulky CH3 group, substitution will not takes place on position 1. Hence, only two products are possible. So कौन कौन से possible होंगे बेटा? एक तो पैरा पे Br लग जाएगा, एक ये वाला possible है, right? And another कौन सा possible होगा? Another which is possible like that is CH3 Here we also have a CH3. So यहाँ पे एक Br लग जाएगा. So only these two product is possible. So ऑप्शन दे रखा है, वहां से आप कर सकते हो. So only this and this two products are possible. ठीक है. So this is all. कल next class में मिलेंगे and we are going to solve some more question related to this hydrocarbon chapter. Yeah, this is a very very important chapter, right? So in tomorrow class also we are going to solve some previous year questions related to this hydrocarbon chapter. Till thank you very much, right? So कल मिलते हैं और कल इसको complete करेंगे, ठीक है?